In these last two problems, we are going to continue looking at how to find remaining factors of a polynomial when given one of its factors. What's unique about these last two examples is here our binomial has a leading coefficient that is not 1. So the synthetic division process here is a little bit more difficult. We'll be dealing more with fractions, but we can do it. And so the first thing we set up is our synthetic division. However, since our binomial does not have a leading coefficient of 1, we have to create it by dividing every term by the leading coefficient. So every term is going to be divided by 2. I always like to write down what the polynomial I'm going to be doing synthetic division with is and the factor now. So divide everything by 2. You have x cubed plus 17 halves x squared plus 23 halves x minus 21. And we're going to do the synthetic division with the binomial now of x plus 7 halves. So here's our new synthetic division process. Let's set it up. We have a solution of negative 7 halves. We've got to love using the fractions. And now we set up all of our coefficients. We are not missing any exponents, so we don't need to insert anything. We can go coefficient of 1, of 17 halves, of 23 halves, and of negative 21. We set up our remainder box. And let's start doing the synthetic division. We drop down the first term, and we get negative 7 halves times 1 is negative 7 halves. And so 17 halves plus negative 7 halves is going to be 10 halves, which is 5. Negative 7 halves times 5 is negative 35 halves. And so if you get 23 halves plus negative 35 halves, that's negative 12 halves, which is negative 6. And so if we get negative 7 halves times negative 6, that's positive, I'll put it off to the side, 42 halves, which is actually the number 21. And so our remainder is 0. And we know our remainder should be 0 because we're told 2x plus 7 is a factor. So what's nice is even though we're working with all these fractions and we have to simplify them quickly when we're adding them, we know that if we don't get a remainder of 0 here, something is wrong with our work and to go back and fix the rest of our synthetic division. So if we take a look at this, we now have our polynomial, and so we factor the remaining polynomial. Which here, that remaining polynomial is a quadratic. X squared plus 5x minus 6. So we need two numbers that multiply to give you negative 6 and add to give you positive 5. That would be 6 and negative 1. So we get x plus 6, x minus 1. And those are my remaining factors. So the process is the same. Set up the synthetic division, perform the synthetic division, should get a remainder of 0, take the remaining polynomial, factor it to figure out what are the remaining factors for the polynomial. It's just now we have to create a leading coefficient of 1 for our binomial. So let's look at one more example. 8x to the 4th plus 32x cubed plus x. Right away, I notice I am missing a 0 x squared term. So I'm going to have to insert that when doing the synthetic division. But before I do synthetic division, I'm doing it with the binomial 2x plus 1. I have to create my leading coefficient of 1 by dividing every term by And you may think, well, Mr. Ansberg, you just missed putting the divided by 2 here because you had to insert that 0x squared term. And I did, but luckily I know that 0 divided by any number is 0. So that 0 is going to remain 0 no matter what. So let's just look at the polynomial. We get 4x to the 4th. We get 16x cubed. And I remember we have to have a 0x squared. We have a 1/2 x plus 2. And we're going to do synthetic division with x plus 1/2. And so there we go. Remember, we're told this is a factor, which means our remainder should be 0. So let's set up our synthetic division. We have negative 1/2. We have 4, 16 to 0, 1/2, and 2. You drop down the first term. Negative 1/2 times 4 is negative 2. 16 plus negative 2 is 14. We have negative 1/2 times 14 is negative 7. 0 plus negative 7 is negative 7. You get negative 1/2 times negative 7, and that's 7/2, which 1/2 plus 7/2 is 8/2, which is 4. And negative 1/2 times 4 is negative 2. We do get a remainder of 0, which means we performed our synthetic division with a fraction perfectly. So now we write down our remaining polynomial, and that is 4x cubed plus 14x squared minus 7x plus 4. Now the overall goal is to factor the remaining polynomial. Now this is 4 terms, so I can do it by grouping, but I noticed there's no way for me to group these to find a pattern. There's no GCF. We do not know the factoring process. It is not factorable. So that is the only remaining factor for us. So even though we have binomials with leading coefficients that are not 1, we can create it by dividing all the terms by leading coefficient, set up our synthetic division, go from there, take the polynomial that remains, factor down to find the remaining factors. There is a brief video after this one that just outlines the difference between our remainder theorem and our factor theorem, the two main focuses of this lesson.